and ways that I view myself as a scientist and how I interact with the world. One particular thing that was I remember from SSP that I wanted to talk about in this talk was being up at Etzkorn Observatory. And when we would go do our observations, we would go up there, the gravel, I still remember the sound of the gravel crunching as you drove out to this observatory, and then scampering out into the dome when you were ready to move the telescope. And we all learned this new word, which was slewing, and you had to yell it as loud as you could to tell the people who were still back in the control room that, or they would yell it and you would watch, and everybody would be trying to make sure the cords didn't get tangled and the telescope went where it was supposed to go, and the dome moved where it was supposed to go. And it was all this new word for me, which was slewing. Now, I had never encountered that word before. It was very much a new part of my vocabulary, and I had no idea that it would come back into my life in a totally different way later on. So today I am the president of a company called Slooh, spelled Slooh, which is all about trying to create access to space for everybody. When I first learned about SLU, I laughed thinking about that memory at New Mexico Tech and yelling SLU really loud in the middle of the night to try and make sure that nothing would get tangled when the telescopes were moving. And now it has taken on a whole new meaning as a way for me to continue the experiences that I had at SSP and help share access to the night sky with everybody. So I'm very excited today to talk to you all about what exactly SLU is, what we do, what our mission is, what our capabilities are, some of the interesting science, and the community around the world that really is the essence of this whole network. So I will start with a video on the next slide and then talk in more detail.
The universe belongs to everyone, but not everyone has access to it. SLU is the online telescope network so that everyone can experience wonder for themselves. Space is big, really big. It's one of the things that can make astronomy feel a bit daunting, but it's also one of the most exciting and awe-inspiring parts of astronomy. From close to home in our own solar system with the sun, moon, planets, asteroids and comets, to interstellar space to capture the stars, star clusters and nebulae in our Milky Way galaxy.
For those looking for viewing options tonight, if it can't be NBC, there's always an asteroid.
By the way, hey Matt, did we just see a plane?
Oh, I just saw a jet!
You know, I've been shaking since about 8 o'clock when I first saw these live pictures.
Now this is happening.
Oh!
Over 20 years of access to the universe and worldwide wonder.
So that's your quick, fun overview of what SLU is in video form, and I'm excited to talk more today about what it is in detail. So SLU is a telescope network built around the world based around the idea that it is human nature to look up in wonder, and that space exploration is a huge part of culture right now, but in many ways it is still inaccessible to most people. While it should be something that's really easy to just go outside and look up at the night sky, I know firsthand how hard it is to see anything except even a few stars when you go outside in many places, especially in city centers. You go outside and you can barely tell there's anything else up there at night because there's just so much light. SLU is built around the idea that we want everybody to be able to access the perspectives of the night sky for learning and educational purposes, and also for just human connection and wonder purposes. I deeply believe that the most powerful response that we get from looking up at the night sky is the ability to pause and say, whew, okay, we're part of this bigger picture. We can breathe for a moment because every single one of those stars up there is a whole different world that we can't even imagine. And that just adds some perspective to life. Um, so the way that SLU does this is we enable space exploration at scale for a large community through our telescopes all around the world, which provide access to the night sky. The platform is about to be translated into 100 plus languages and available to anybody for the cost of a cup of coffee. Anybody can join to learn about space, experience space, talk about space, fall in love with space through these telescopes. And the whole goal is to restore the connection to the wonders of the universe for everybody, whether you're a scientist or not, so that anybody can have that amazing minute every night or minute, 5 minutes every week of looking up at the night sky. So SLU is built. This is a little bit of my team. We have people who are from education, space science, and earth science worlds, learning experience design, software development, robotic engineering. I joined SLU out of my PhD program. When I finished my PhD working in exoplanet science, I had the opportunity to join this team, and I got really excited because it's a fun group of people of all different types of backgrounds working toward this goal of connecting the world with wonder. We have everybody from technology backgrounds to engineers to education, and our team is growing. It's only about 20 people right now, but that's almost doubled since I joined a year ago. So very exciting time to be a part of Team SLU, and I am so grateful to this team that I'm here representing today because it really is a whole team effort. So SLU was actually founded back in 2002. The first observatory opened for SLU in 2003 in the Canary Islands at the Institute of Astrophysics there. 2006 was when our patent was awarded. The patent allows for imaging recipes in the way that the photons that hit the telescope appear on your computer screen, is basically the essence of that patent. The citizen science program on SLU, which I'll talk about a lot later, actually launched in 2008, and the first asteroid observations using SLU telescopes began then. The expansion to Chile, where the first observatory there was opened, was in 2009. We had major star parties back in the early 2000 or like late 2000s before 2010, with that Google lunar eclipse image from the video. Later on, there was a launch of what we call advanced missions, which are the ability to schedule your own missions using not just a list of the SLU 1000 objects, but to pick your RA and deck, as SSP astrophysics participants are familiar with, and get back the FITS data. And through that, the platform really went through evolution into an education-based platform. So 2019, we started gamifying the platform and including different ways to uh, not just go look through a telescope, but also learn about what are you seeing. And as you learned, you earned gravity points. We expanded into the education technology world through quests, which are our NGSS aligned learning activities that were developed with the NSF in 2021. Australia opened in 2024, which got us the 24-hour global telescope coverage. Right before I joined, they partnered with Skyfi, which is a Earth observation provider. It's like a collector of data from different Earth observation satellites that are then available to members on SLU to be able to do Earth science as well as space science. Um, Won the Fast Company Most Innovative Space Company Award, and by 2025, we now have over 500 educators and 100 plus higher ed institutions using SLU, as well as our consumer members. I'm most excited about that blank little corner here, which is what comes next for SLU. We have a lot of new things coming, including new telescopes and expansion into really not just the astronomy for people who are already curious about astronomy, but astronomy for people who have never touched it before. I want so many more people to experience that sense of not just learning about science, but doing science. I had the opportunity to teach with SLU in graduate school before I joined the company. And one of the most amazing things was I was teaching this program called the Warrior Scholars Program for veterans who are transitioning into undergraduate degree programs. And I was working with these students who were incredibly smart, but for the most part lacked a lot of confidence about their own abilities. And we were doing this project. They do a research project as part of the program, and they were measuring some of the features on the moon and learning all about lunar exploration. And we used SLU in the class, and I had them all schedule their own observations of the moon on SLU. And the way that the students went from just looking at a picture and having no attachment to what they were doing to, oh, I took that picture of the moon. I know what I'm doing. I'm the scientist engaged in this was mind-blowingly powerful to watch. And it reminded me so much of my experience at SSP, where I had gone from just learning about physics and loving it to actually doing the science myself and feeling like I could be a scientist. And I'm really excited for SLU for us to be able to expand that feeling of being a part of science, especially at a time in the world when science is misunderstood in many ways and also more important than ever. So, a little bit more about SLU's observatories, especially for the astrophysics side of this crowd. I love learning about our telescopes. Our observatory manager is incredible, and he has built out this network of telescopes all around the world. We have telescopes currently in Australia, in Chile, and in the Canary Islands, and we have more to come. One south planned observatory site in the southwestern US opening soon, as well as additional sites in Chile and Australia. The Canary Islands Observatory is where we have most of our instruments. We have 5 different telescopes there, including one of our half-meter telescopes. It's also where we have our spectroscopy capabilities, as well as our first solar telescope. All of these live in the beautiful Institute of Astrophysics on the Canary Islands, so they are in pristine research quality condition skies, but available for anybody. They're all architected so that they each have a capability that they're best for. And the way that the platform works, when people schedule missions, there's varying levels of difficulty with which they can schedule them. And for those who are the most new to the field, it makes it really easy because it pre-selects filters, it pre-selects which telescope, and pre-selects the time to make it very simple to say, okay, I want a picture of this nebula or this galaxy. Let me help you find it. So when you see this category over here for which are they best for, you can see that we really have optimized for all different types of objects with this fleet, even in just the Canary Islands. We also have 3 telescopes in Chile. More trying at the southern skies was the first southern sky observatory for SLU to be able to get both hemispheres. It's also where we have our one of our lunar telescopes for high magnification of that, and we have a new solar one coming in Chile very soon. And then in Australia, we only have the 1 telescope right now, but it's our twin to the Canary flagship. It's another half-meter telescope to be able to get the southern faint and deep sky. We also have another one coming soon to Australia, as well as another lunar scope coming in planned for here as well. As I said, we also have more lunar and solar scopes planned. One of the things that I've learned about being in this job is that the things that most people are interested in the night sky are the things that we see the most, which are the sun and the moon. So being able to teach about the surface of the moon, teach about the surface of the sun, and how they change and evolve over time is the best way to get people who are nervous about touching astronomy or touching science into learning, because we all have touched these 2 objects and seen them in our own daily life. So we have that connection to them that's really easy to tug on that string and say, okay, you saw the moon in the sky tonight. What if you see the craters on it? Why is there that Terminator line? Why do we not see the backside of the moon? All of those kind of things. So it's a very tangible way to get beginners into excitement about what they're seeing. And then once you catch the bug of astronomy, it's hard to go back. I will say it's also particularly fun to talk about the sun because coming up we have a total solar eclipse next week, or I guess this coming week on Wednesday. And for eclipses, we live stream views of the eclipse from all over the world live from SLU so that anybody anywhere can watch. For this one in particular, it's people are talking about going to Iceland or going to Spain. We'll get a little bit of it, and it's much easier to sit and be able to watch it from home and much more accessible to do so as well. So I will be actually hosting SLU's Star Party for that on Wednesday, and it's my first one I'm hosting, and I'm very excited about it. One of the amazing parts of SLU with my astrophysics hat on is the large scale data that we have. So SLU has been around for over 20 years, and in that time has collected a huge amount of data. So there's a lot of interesting science to be done with this repository of data as well. Um, when I was one of the things that I did when I was put into this talk was think about all the parallels between the work I do at SLU and the work I did at SSP. And I came across this picture on the left from SSP where I think it was like one of the last nights before the end of the program, and everybody had all their asteroid observations. So we were just getting to do observations for fun. And we took this picture of the Whirlpool Galaxy, and it was the background of my computer screen for a very long time. And I was really excited about it. And it was actually one of the first objects that I imaged on SLU as well. So it's fun to just make those connections and think about how excited I was to get this image, but also how much work went into learning how to do it at SSP and how incredible it is for anybody to be able to go in and get access to an image like this that they can take themselves. So for SLU, this is just one Im those are just like this is one image of our archive of images. So I pulled a couple of my favorites here to show you. We have a comet, I believe it's the Christmas tree comet up there. Or that was a nickname for it on SLU. And then a couple of my favorites of the Tarantula Nebula, the Running Man Nebula, the Western Veil Nebula. These images are eye-popping. They are fun to see, but they mean the most because they were captured by individuals on SLU who were able to schedule their own missions and learn a little bit more about what they were seeing. And they're not just images that, I mean, I love Hubble images to be clear, but they're not just Hubble images that can sometimes be a little bit hard to understand. This is putting it right into context for anybody who's curious. Uh, so the archive of SLU, as I was saying, is something that I am particularly interested with my scientist hat on because we have these images from over 20 years of these telescopes collecting data. This is just a very small sampling, but if you watch this change in the archive, you can see the images of Jupiter over time in the telescope, and then a couple others, including Saturn, we'll be able to see the rings tilt over time, which is pretty fun. And you can also see the telescope technology and our filter systems and our processing systems get better, especially with those Orion Nebula images. These are a snapshot of just a couple of images and objects. We have a couple million of them, well, 17 million of them almost, that have been captured since 2004. And I'm very excited for future projects going in and being able to look at the data within this and figure out what kind of science we can uncover from it that will be unexpected, interesting, and fun. I am a big believer in archive science. There is so much that we can learn from what is already in the archives of different telescopes. My entire, or not my entire, but part of my PhD research actually used archival exoplanet data. And I think that there's so much to learn from new data, but there's also a lot to learn from old data. So at SLU, I'm particularly excited about what we can learn from this set of images and what we can use like use for community purposes and have citizen science projects work with this incredible bank of data. So citizen science is actually already a huge part of SLU, and while that large-scale astronomical data set can be a new source of new projects, there have been a number of projects that have been ongoing on the platform for quite a while. Um, Again, drawing the connections, that image or the GIF on the left-hand side is a Snapchat that I sent pretty much everybody that I knew in 2015 when we saw our asteroid move across the screen for the first time, and I was so excited. And then the one on the right is Tony Evans, who is the leader of the SLU A team, which is our asteroid citizen science program. This is one of the asteroids that he captured using SLU's telescopes. The really fun part about the A team on SLU is that they are totally self-organized. They developed their own list of here's how to observe asteroids using the SLU telescopes in the SLU system, and then became an organized group on the platform that would post here's these asteroids that need to be observed right now or that are good targets for observation, self-organizing to plan and be able to do that. And as a result, have submitted over, I believe it's over 20,000 submissions to the Minor Planet Center from SLU. We also have people who do variable star research using SLU data. In particular, there's a really fun story of a student named Michelle Park who did some variable star research while she was still in high school on SLU and then ended up going to Stanford to major in physics and is now, I believe, graduating this year. So we graduated from Stanford with a degree in physics and has continued to do astronomy and astrophysics in college. Um, I love these projects because they are not only accessible to anybody on the platform, but they are a way to engage and get into what I was talked about at the very beginning with the actually just doing science and not just learning about it. So I'm very excited about adding more citizen science projects and opening the door for more to coalesce from people's interests. The SLU community is my favorite part of my job, my favorite part of the platform, the thing that I think just makes this whole idea so special and takes it from just being telescopes and satellites to actually a whole community. So, as I mentioned, when you take an image on SLU as a member, you get your image back. But what you get to do with it then is write what we call observations, where you share your image with the community on SLU, and then you can also share it beyond the platform as well, and write about what you see. And when you read through what people write, they write poems, they write about the science, they write about what it made them think of, they write about what it reminded them of. They write about stories and connections they have to those objects and why they like them. And altogether, we believe that this is the largest recorded log of human observations of the night sky in one place. And it is what takes it from just pretty images to people's perspectives of the night sky. So I actually want to show that to you right now. I think it's way more impactful to show it than to just hear me talk about it. So this is the inside of SLU. This is our community page where members share their observations. So you can see here, they range from these very scientific descriptions of what is being seen, what is being observed, to more just like observations of probably students who are saying, okay, hey, look, this is fun, and engaging with science in a different way. I love there are a couple that I saw earlier where somebody was saying this is the Dumbbell Nebula, but I actually think it looks like something different. Um, or I'll even just scroll through and you can see these different perspectives people have. I think this is the most fun part of the platform by far. Um, yeah, it's very special. Um, to get perspective on who is sharing these, we have everything from students who are in schools who are using this in astronomy and physics courses to 6-year-olds who use it as an after-school enrichment activity. I got to interview two of them who live in Utah, which is where I grew up, and they were so fun to talk to because they get on the platform after school as a way to keep doing science work and just their mom encourages them to get on and learn about science. But they share their observations and they'll share things like, oh, here's the Cat's Paw Nebula. I like it because I have a cat. And to me, that's the most special kind of observation to see because it is a kid connecting their own life to science and being able to say, this is why this matters and this is why I like it. And that starts that whole identity building process of moving toward feeling like they can actually be a scientist. And then we have researchers on the platform who share their actual research findings with SLU and also people who are another favorite story is somebody who is in Scotland who is 80 plus years old and he has had macular degeneration. So he can't use his backyard telescopes anymore. But because he can blow up the size of the images on SLU so much on his computer, he can still engage in amateur astronomy even as at his age with the macular degeneration. And that is the name of the game when it comes to accessibility is reaching all those ages and all those different perspectives. So, moving back over to the talk side, I want to talk a little bit more about how I see SLU fitting into the future of science education. So I am the daughter of an educator. My mom is a professor of education, so I have grown up steeped in education and what makes it work and why does it work and why does it matter. And especially science education is something that is near and dear to my heart in this world, we need it more than ever. And I'm really excited about how SLU is already created an impact in science education. This picture up here is from a summer camp that ran this year called Camp Cosmos by Dr. Jason Steffen at UNLV. And he had a number of middle school students who all were using SLU during a summer camp that he organizes to learn a little bit more about the night sky. The way that we do it on SLU is through this scalable shared mission reservation system. So, as a member, students will each get a certain number of missions that they themselves can schedule, and then they can also join an unlimited number of other people's missions, which enables the collection of an incredible amount of data for every single student. You also can watch the live feeds of the telescopes, so you get them asynchronously afterwards, but you can also watch it live and snap images and be able to access all the different catalogs and coordinate missions and image processing presets that can really take it to an advanced level. What you do with that data from an education perspective on this platform is create what we call posters at the end of every quest. This is a solar system explorer quest for elementary school where you're learning about the sun and the moon and you pick another planet that you want to learn about. And they're all NGSS aligned and gamified activities for learning that can help improve students' outcomes in science by giving them that identity of I'm not just learning about science, I'm actually doing it. It's also used in higher ed, which I'll talk a little bit more about later. One of the really fun things in the platform that I have really enjoyed getting to help build out in the last year is called the Gravity Awards. The Gravity Awards are effectively a way to gamify science communication. So in this case, it's helping students who are already excited about sharing science share their work more broadly and then be able to reward them through what we are leaderboards. So in this case, it shows the high school students who were at the top of the leaderboards at the end of this year who had shared the most observations on SLU, and the community had reacted and given them gravity points, which is how this leaderboard is built. Around it, we're trying to really help encourage communication and science communication skills, collaboration to be able to contribute to group missions. Being part of the Gravity Awards is a way for students to lead projects, organize challenges, really inspire their communities to learn more about science and space, and really lean into the creativity side of the platform. It's extra fun to see the different ways that students come up with to celebrate what they've learned and share what they've learned with themselves and their community and connect it to the people in their lives and what they might be experiencing. These are some of my favorite posters that come out of the quests. There's a couple different styles that we have. There's the more collection style quest. So this collection poster on the left-hand side is all the objects in the Messier or a selection of objects in the Messier catalog. It takes a long time for anybody to complete this poster. And so students are generally very proud when they do. There's also some that are more crossword or not really crossword like word search style quests, I guess how I would think about it, where you're solving a mystery, you're trying to put the puzzle together to be able to complete the poster, and that's what the Blinking Eye of the Gorgon is about, and learning all about binary star systems and also some of the mythology connected to the night sky. These quests are not just a way to learn about science, but also the history and culture and ways that people have connected with the night sky in the past and the present. Now, this is my favorite poster that gets made on SLU. This is about the life cycle of different stars. And I think about the number of times that in both undergrad and grad school, I drew diagrams like this and had professors draw diagrams like this in lectures. And every time they're trying to sketch what happens to the different types of stars, what happens, how do they evolve over time. And in this case, instead of just those sketches, you capture images of stars of different masses. You capture images of supernovae remnants. You capture images of the planetary nebulae and the white dwarfs, and then where they live and how it all evolves over. And it's just like you can actually see it with the real images and the real data. And again, just taking it from something that is abstract to very real, I love what this can do for learning because it connects that sense of this is not just some sketch on the board, this is real and in the universe, and I took a picture of it. Next up for SLU is something that I am really excited about, which is not only looking out at the universe to look at what is naturally there, but to look at what is not so naturally there. For those who haven't heard the term before, space situational awareness is the whole field of trying to understand what exactly is in the night sky that is human-made, and particularly very close to Earth. So looking at the numbers of satellites that are around us, trying to understand what exactly are they made of? Where are they? How big are they? Are they going to hit something that we care about? All of that falls under this category of space situational awareness. Now, on SLU right now, we already have the telescopes to look out into the universe. We have satellite data to look back down to the Earth, and we are adding the capability to have specialized telescope systems that will look out into the universe, but with a focus on capturing these objects that are circling the night sky. This image always blows my mind, and every time I go back to recreate a slide that has this particular image on it, the numbers creep up quite quickly on the legend. So what this is showing is all of the stuff that is around the Earth right now that is human made. Um, the active satellites, we are up to almost 17,000 active satellites, about 3,000 inactive satellites, a number of objects that are uncategorized, which is usually like just junk of things that have broken or crashed or small parts and pieces. Although the fact that they're uncategorized, there leaves room to explore there, old rocket bodies, and then also almost 10,000 pieces of debris. Every single one of these pieces is something that is important to understand for multiple reasons. There's the scientific reasons of just like what exactly is up there. There's safety reasons for astronauts that are, for example, on the International Space Station. If any of this hits the International Space Station, it can puncture it and be life-threatening. And as we launch more and more humans into space and into orbit around the Earth, that safety becomes really important. There's also national security concerns for understanding what exactly is up there, where is it, how is it moving, who owns it. And then there's actually really interesting legal questions about, okay, so all this is up there. If they crash, who's responsible? Like, what is the protocol for figuring out how to move it? If something's going to hit my satellite, can I move it or do I not have permission to do that? How would I get permission to do that? There's a whole new frontier of legal work being done there, which I find totally interesting. And then there's also environmental questions. Okay, this is all out there. We know that it's going to face drag in the atmosphere and might come back down in. What is that going to cause to the Earth? There's already studies that show that increasing the amount of metals in the atmosphere with all this burning up of debris as it re-enters can cause problems. There's also stories of debris making it through and hitting people's houses or hitting people themselves. Um, it's a little more rare. A lot of the Earth is ocean, so not as common, but it has happened. And these numbers are just going to continue to grow. So the people who track this the most are usually companies that are focused on national security and they sell the data back to governments, which are, of course, very interested in this. But from SLU's perspective, we're really excited about the idea of making this something that is more democratized and in the name of accessibility and access to understanding our own world, how can we help other people and help our whole community understand what is up there by having people on SLU actually be able to track these pieces of debris and these active satellites, etc. So, with that in mind, we are very excited to have Dr. Reba Jha, who has joined SLU's board of directors earlier this year. He's a MacArthur Fellow and a UT Austin Professor of Aerospace Engineering and also the co-founder of Privateer Space. He joined as a leader in this space domain awareness world and is going to be helping us as we incorporate his network of telescopes, which are the Astronet telescopes, built at UT Austin and part of UT Austin, into SLU's capabilities so that we can do this orbital debris tracking right from the platform so that anybody can look out into the universe and see what are the astronomical things that are out there, what are the natural things, and then what are the human-made things that are there. And this really matches with SLU's belief that the universe belongs to everybody, and we all have a responsibility for understanding what we put into orbit and what it will do and what are the policy implications, etc. Understanding it is just the first step. And then how do we engage communities in understanding what to do about it? I'm particularly excited about this project. At the end of the day, SLU is really about protecting science and protecting awe. When I think about the first experiences that I had with the night sky, they were all about taking that time to step back and to pause and to gain a little bit of perspective on what's happening in the world around me. It was to learn the science, but it was also the feeling of just breathing in the sight of something so much bigger than us, quite literally. I'll never forget when I was a TA in New Mexico, one of the responsibilities was to drive the participants up to the observatory. And the first time that I did that, I will never forget the look and the sound of one of the students who saw the Milky Way for the first time and that night and got out and had never seen that, grew up in a city, had never looked up at the Milky Way and just like practically fell over with like mouth wide open, looking up in awe. And to me, that's what all of this is all about at the end of the day. Doing the science is incredible and so important, and learning and connecting with other people, absolutely incredible. But having those moments of connection with this beauty and wonder in the night sky is what I've always loved space. And at the end of the day, that's all that we're trying to do with SLU at its core. Um, I said this a little bit earlier, but I want to say a little bit more about it. One of the reasons that I really care about this in this day and age is that as science and the scientific method becomes something that is not as broadly understood in the world anymore, and as scientists come under attack, I think it is more important now than ever that we cultivate more people with a scientist identity as part of themselves. Even if it's not their career title, it's not their career path, it may not even be what they pursue in college, but more people who feel connected to the act of not just learning science, but of doing it. And we are so lucky that space is one of the easiest ways to make that transition happen because pretty much everybody gets excited about the night sky. And if we can take that sense of wonder and that sense of awe and connect it a little bit to how does science work? Why does science matter? Why do we actually care about studying these things? What is the value of funding organizations like NASA and all the other scientific research institutes out there? Why do we care about it? And then what is the process of actually doing science? It's teaching exactly what we teach at SSP, where it is an uncertain project with not a guaranteed right answer. And that uncertainty and living in that space of we know a lot and we have so much more to learn will, I believe, protect the fundamental value of science for society going forward. And it is my pleasure and joy to wake up every single day and get to be a part of an organization that is built around trying to share that perspective of connection and wonder with the night sky and with science. SSP is an incredible organization that is also so deeply tied to that mission, and it's one of the reasons I've stayed so connected to the program is that I think that developing those identities of a scientist in everyone so that we all can experience that sense of curiosity is so important always and more important now than ever. Uh, I want to end this with one last video and plug for the SLU's star party for the solar eclipse this coming Wednesday. So no matter where you are or where you live or where you'll be on Wednesday, you can tune in and watch the total solar eclipse happen live on SLU's YouTube channel. And I will be very excited to be sharing that perspective of awe. Anybody who's experienced totality before knows that when you watch that moment of darkness, it is just jaw-dropping, amazing. And it's going to be such a fun thing to share with the world. And there's more to come for SLU and SSP, which I'll let Kristen tease to the level that is public right now. But I'm very excited to have shared more about why I care about this today and how it connects to the journey I've had with SSP. And I'm looking forward to answering any questions.
Thanks, Emma. That last video gave me goosebumps as somebody who did not attend the program and is not a scientist by trade. It's exciting to know that that's accessible to somebody like me to explore the universe like those who do it for a living. So thank you for sharing that. And as Emma mentioned, we will be partnering in something very soon. let's say early to mid-September, you will be hearing from SSPI on how you can access SLU through SSP International. So I would love to open the floor to questions because I'm sure there's some of you out there that have some as professionals in the field and not. So feel free to come off mute, put them in the chat, and Emma would be happy to answer.
Well, I'm going to jump in. Hi, Emma. Nice to see you
Hi.
again. Um, I'm Bonnie Mount Weiss. Let's see, just SSP 89, TA 93, and then I've been a trustee as well. And let's see, on the admissions committee for 18 years. It's been a while. Um, anyway, I had a question I was curious about. So, obviously, with your inclusion of space situational awareness, you're aware of this, but I know for observational astronomers, the explosion, well, not literal explosion most of the time, but explosion in the number of satellites, and especially the Starlink satellites, causing background streaks um, in their images is a thing that happens. I was wondering how that's impacting your um, operational I don't know. How is that impacting you operationally in terms of the observations that you're making? Is that something that you schedule around? Is that something that you're maybe looking to do in the future? That's my
Yeah.
question.
Yeah, no, it's a great question. So it's interesting if you go back through our catalog, we notice more and more satellite streaks in the imagery than we used to, for sure. There are far more that capture it, and there are actually people who are usually the members of the A team, who have already started to try tracking satellites using SLU's existing telescopes, and have been able to do so. It is unlikely that we're going to have to start scheduling around them in the near future, with the exception of if there are a bunch more of the very large satellites launched. The Starlinks are pretty small, so their impact is more minimal. But I mean, we probably have all seen the news of Reflect Orbital in the night sky. So they're trying to basically beam back sunlight. So we would definitely have to schedule around that.
Oh,
That is something that is of great concern to the astronomy community right now from an observational perspective, because they're trying to basically light up the darkness, which obviously causes problems. For the Starlink ones, we don't necessarily have to at the moment. But that number, I mean, I've been giving talks that include images of that map of satellites for the last, call it 5 years. And that number has gone from 10,000 to 17,000 in that time. So, and I think it's going to increase much more rapidly in the coming 6 years. So we will have to start scheduling around that. We are lucky, or not lucky, it's not a lucky thing, it's a good citizen thing, but there are a number of satellite operators that have engaged with the astronomical community to try and understand how their satellites reflect light back that causes problems for astronomy. And there are ongoing efforts, especially at an international level through the United Nations, to work with satellite operators and be able to paint satellites differently, shape satellites differently. For radio observatories, turn off their basically the stream of radio data that would come off of a satellite and mess with a telescope while they're going over big radio quiet zones. So there's work to be done between the two communities. We are not super concerned about it day to day yet, but I would add the yet on the end there.
okay, thanks.
Yeah.
We had a question in the chat. Do you also do near Earth asteroid looks?
Yes, we do. That is the A team's mission, is looking at all the near-Earth asteroids, and that's our 20,000 Minor Planet Center submissions that SLU's community has done so far. Yeah. Um, Yes, the night sky gaze. I see that in the chat too in New Mexico. It's a beautiful place for it. Um, would love to chat about that. That'd be fun.
Looks like there's going to be a new observatory in Taos. That's what somebody dropped in the chat.
That's
John,
exciting.
yeah. Any other questions for Emma?
Yeah, no observatories in Asia right now, although we're actually in conversations to potentially have one in either India or Pakistan or both.
Uh, I had a question on I'm Yipsira from 26
Awesome.
and like we had to use LCO for our observation like once because of the weather. And I was wondering if like SLU is somewhat similar to that and if they're like in the near future it would we would like SLU would be associated with SSP and like maybe even become like the main online resource for observing.
So it is actually in some ways similar to LCO. I think the LCO's interface is built more for researchers, but the same principles apply. SLU's interface is built so that anybody can come in without necessarily having scheduled a mission on a telescope ever before. We have chatted with the astrophysics team at SSP, and there's potential for SLU being part of programs in the future. I think one of the beauties of this is that in some ways, especially for SSP, the more telescopes, the better. So, excited to help be a resource for this community. I see a question in the chat for how is earth warming and more moisture in the atmosphere affecting our observations? That is a great and very specific question that I don't have the answer for at the moment, but I would love to actually ask that of our observatory managers and look at the data for it. I know, for example, in Chile, this is not necessarily that exact question, but how weather changing is forcing our telescopes to change. The number of nights that we are able to open our Chile telescopes during the rainy season has decreased dramatically as the number of rainy days and storms has really grown, especially this particular season. Um, it's been uh, yeah, quite dramatic. And I think we're going to only see more and more of those extreme weather events that are going to cause impact to the telescopes. We don't develop our own telescopes and equipment. We procure it. Yeah, PlaneWave is one of our favorite companies. Their telescopes are incredible. And we use a number of them as well as a variety of others, but it's all, we can put it together from different providers already. We don't develop our own. Um, Yes, yes, directly with telescopes. I completely agree. I think that the ideal version, John, of the way to see the night sky is to go through a telescope that you can like put your own eye to and also look directly up at the night sky. And then if you don't have access to that, be able to go through the internet. But it's definitely better to go be in the place itself. When I was in graduate school, we observed with the Keck observatories in Hawaii, and it was much less fun to sit on your couch in Connecticut and like watch the screen collect the photons than it would have been to be in Hawaii on the top of those mountains looking up at the telescopes and up at the night sky and what they're seeing there. Other question, are any of your observatories able to view asteroids that are between Mars and Jupiter? Yes, I believe so. Um, we have a number of near Earth objects and then also the ones that are further out that would be visible. Yes. Learned a lot from Pioneer 1 and 2 about the edge of the solar system. Are your telescopes able to confirm anything that we're learning from the pioneers? That is a great question. I do not know. I'm not as familiar with what is coming in recently from the pioneer data. I would love to learn more and see what our telescopes could engage with there. And then does SLU have exclusive access to their observatories or do you timeshare? No, it is all, we own and operate them, so we have exclusive access to the time. And then I think I saw a question that I missed about radio telescopes up there. Um, we do have plans to include radio astronomy in SLU's network coming in the next year.
That's a lot of information.
It is.
A
I
lot.
love all the questions.
Yeah. No, it's great. We just have a few more minutes left of the hour if anybody has anything else they want to ask of Emma. Feel free to come off mute or continue to add to the chat. These are some great questions. I see Emma tomorrow. The first thing she does is ask the two questions she doesn't have answers for of her observatory staff to make sure that
Yes.
she's getting data on it.
How do you decide on the locations? So the original plan for the observatories was to really try and make sure that they were in the same places that research telescopes are, to so that they're not just like a backyard telescope, which are wonderful. Don't get me wrong, they're wonderful. But we really want to try and prioritize the high and dry places where you're going to be able to get the best seeing and the best weather, ideally, and truly get research grade quality images. So as we're prioritizing other locations, we're looking at the variety of places on the globe so that we can get maximum coverage. Right now, we have basically 24/7 coverage with the asterisks of weather. And we would love to be able to be a little bit more redundant against weather. So adding more places that we can be protective of that. And then also really excited about working with some partner organizations and partner collaborators. The potential telescope that I talked about in Pakistan would be in partnership with a woman there who has named Mirwat, who has been using SLU with girls' schools for a while, and we would love to be able to support the work of people who are on the ground in various countries using SLU, and bring observatories to where they are, so that just as John was talking about, you can go and actually go see what an observatory looks like in person and get to experience that because it is such a special moment. Um, I
This is
see.
a special question, Emma. We never get this question. So,
Yeah.
um, did you see the one where Daniela asked, "What was it like coming back as a TA? What inspired you? How did you apply?" She would like to do the same.
I love that question. I loved being a TA. It was particularly special because I got to go back to the same teaching team that was there when I was a student. So it was extra fun. I went the year before my senior year of undergrad. So it was a great time because I was also thinking about applying to graduate school. And it really was also kind of a stressful time between junior and senior year. So it was extra fun to go and reconnect with that. I sound like a broken record, but reconnect with that feeling of learning to be a scientist and do science. And I loved getting to connect with all the participants. They're incredible. And seeing the experience from a different side was really fun. So definitely would recommend. I would direct you back to the program to ask about how to apply because I'm not quite sure what the process is right now, but I'm sure they'd be more than happy to tell you.
Yes, we can absolutely help you. You can reach out to me, SSPalum at ssp.org, and we'll help you with that. And then looks like David has one more question for you, which is also related to SSP. Besides your career in astronomy, how did SSP change your life? We're trying to ID the benefit of SSP on our students.
Many ways. So I think I've already foot stomped the over and over um, be the identity of a scientist. That was that for sure the first way that it helped me. The community, the people around me who I made friends with and I'm still friends with to this day from my program, the mentors from the teaching team that are still mentors in my life and who I'm so grateful for. The um, challenge was particularly valuable to me. I was somebody who came from a public high school in Utah where I was trying to get the most challenge that I could in that experience, but SSP really took it to a whole new level and made me believe that I could apply to Ivy League schools and have a shot at not just getting accepted, but actually being able to not just survive, but thrive as a student there. And also, I think seeing the different ways that people are scientists, having the speaker series had a really big impact on me. Where there was such a variety of topics and a variety of people. And it was such a good lesson about how scientists are people and people craft their lives in different ways.
That was beautiful. Thank you, Emma. And part of her academic team is on today, and it was also her nominator for the Young Alumni Achievement Award that she won last year. Adam Rengsdorf is on. Hi, Adam. We missed you this summer. Um, but yeah, thank you all for being here today and asking Emma all the questions. And Emma, I mean, I'm going to dive into SLU very soon because I feel like there's a whole world out there that I haven't explored. And some of you may have access to that too through SSPI and SLU's partnership coming in September. And stay tuned for our next Curiosity Lab, which dives into AI with another Young Alumni Achievement Award committee member. That is on September 13th. It's artificial intelligence. How did we get here and what do we do with it? She has also wrote a book on AI and she works every day in AI. So it's definitely a not one to miss. But yeah, thank you, Ralph, for being here. Thank you, Emma. If you have any questions post Curiosity Lab, just send those over to SSPalum at ssp.org and enjoy the rest of your afternoon, everyone. Have a good one.
Thank you all.
Bye.